In this lesson, we are going to talk about geometries. We've already used the box geometry, which created this box in our scene. So as you can see, I have already my starter set up running. So take your time, launch the starter, and then get back to the lesson. But before looking at all the available geometries, what is exactly a geometry in Three.js? So yeah, first, a geometry is composed of what we call vertices. So I can do some drawings to help you understand this. But a geometry first starts with what we call vertices. Vertices are coordinates in space. So for me, it's only in a 2D space, but think of it like if it was in 3D. Those are called vertices. The singular is vertex. And those vertex are linked to create what we call faces. And we get something like this. It can be like that, it can be like that, maybe this one is linked like this, and this one is linked like this, and at the end you get a full geometry. Alright, so we need a way to create vertices and create faces. Obviously, this geometry, as we did in the previous examples, can be used to create what we call meshes, but it can also be used to create particles. When using geometries to create particles, we get a particle for each of those vertices. So forget about the faces. What we get if we use geometries for particles is a particle here, a particle here, a particle here, and it goes on and on and on. So I would get one here, one here, one here, one here. We are going to do that in a later lesson. For now, we are just going to focus on the geometries to create what we call triangles, what we call faces. So a faces is just a triangle between three vertices. In the geometries, we can store more than just the vertices coordinates. So each vertex, each of those vertices, each vertex will have the position. So in this vertex, I'm going to have the position, but I can have other data. I can have what we call UV coordinates, and I can also have what we call normal. I will explain to you both UV coordinates and normals, and I can also have everything I want in here. I can have color, I can have random values, I can have some kind of size, which will enable the control the size of the particles. We can put anything we want in those, and we are going to do that, but later. So, okay. So this is just the concept part. We have to understand this because we are going to create our own vertices and we are going to create particles and we are going to send different data in those particles. But for now, we are just going to test built-in geometries. So Three.js built-in geometries. I'm going to show you a lot of geometries. All of these geometries inherit from the geometry class. So this one. This class has many properties, but also methods. You can see some of them here, and they are going to be interesting because you have things like rotate X, rotate Y, rotate Z. You have also something like scale, translate. These are a way to translate, to rotate, to transform the vertices. You're not going to move the mesh, you're going to move the vertices of the geometry. Sometimes it's more interesting to move those vertices. We will have maybe one or two examples in later lessons, but usually we just create the geometry and then move the mesh. So with the geometry, you create a mesh and you move the mesh. So don't get wrong about those. We are not going to use them too much. All right, let's just discover almost every available geometries. Why are we going to do that? We are not going to test them all in the code because it would be too long and not very interesting, but it's always good to know that those things exist in a library, in an API, by using the documentation. It's just good to know them because if one day you can use it, you might need something like that. If you don't even know that those classes, those methods, those things exist, you won't even use them. You'll be just stuck. Maybe you will try on your own. So it's always good to just go through the different features you can have. We already know the box buffer geometry, so we are not going to spend too much time on it. Also because after that we are going to go deeper into that geometry. So yeah, it's just a box geometry. As you can see, most of the geometries in the documentation of Three.js have examples. So here I'm on the box geometry, and like I see in box geometry, you can open that debug panel. I'm going to call that a debug panel and play with it, which is just great to understand how it works. We are going to learn how to create these kinds of panels in a later lesson. So yeah, this was the box geometry. Cool. This is the plane geometry. It's not a flying plane in the sky. It's just two triangles. And the good thing is that we can see those triangles too. All right, and every time you have an example of code. So this is just a plane. Let's not lose too much time on it. You have a circle geometry with a lot of parameters. You have a cone. Remember this one. We are going to use it, but in a different purpose. You'll see later, in the later lesson actually. You can create a cylinder, so you can create pillars. You can create the base of a rocket, stuff like that. You can create a ring. So this is not like a 3D ring. I don't know if no, this is not a 3D ring. It's more like the circle, but with a hole in the middle. You can create a torus geometry, which is more like the ring, how we would have thought, like a ring in the Lord of the Rings, stuff like that. You can write things, write letter, Elvish letter on the side. We have the torus knot. I really like this one because it really helps to test things and to test how light bounce on the geometry. So yeah, it's a pretty fun one. And obviously you can control everything on it. You have the dodecahedron geometry, which is that. All right. Maybe you can create like a football ball. Okay. Octahedron geometry, which has 8 faces. Remind me of Evangelion, for those who know. We have this tetrahedron geometry, so you can play with it again. As you can see, we can control the level of details. We can do that on the previous one, maybe, I don't know. But yeah, we have a lot of controls over those. So this one was a tetrahedron. Again, another of the same family. We have a sphere. This one is very used. So we can do, if you want to create, let's say, a planet, you will create a sphere with a lot of segments. So we have enough details. And then you put the right texture on it, and you can have a really realistic planet. We have something called shape geometry. What a beautiful heart. Shape geometry is based on curves. More precisely, I think it's on Bezier curve, but I think you can use other things that are Bezier curves. We won't dive too much into this one. But yeah, you can have details. So you provide a shape, which is like a spline, and it creates like all the things, all the faces inside of it. We can create a tube that will follow a path. Great if you want to create wires, stuff like that. We can create an extrude. So this one is really special. It's more like the what's going on here, the chanfrein, the bevel, some kind of bevel. I never use this one, never. We have the lathe. I don't know how you say this in English. The idea is that you provide only. Can I stop it turning? No, I can't. You provide values of this line, just one line on the side, and you create a revolution. So you can create like a glass. You can create just form like this, and that will do a revolution. And finally, there is the text, and we will be able to create a text. And we are going to use this one in a later lesson to create a really cool experience with a text inside. So you're going to put your name or anything you want in it, and we are going to add a lot more. So it's a cool, good experience. All right, this was the geometries. Just keep in mind that they exist. Maybe we will use them, maybe not. Maybe you can create them on your own. It's up to you. By combining those geometry, we can create pretty complex shape, meaning that if you want to create a house, you don't have a house geometry. You're going to use a cube for the walls. You're going to use another cube, I don't know, for a wall on the side. You're going to use a sphere to create bushes, a cylinder with a sphere on the top to create a tree. And when you combine those, you will get a pretty cool result. And if it's too complex, obviously you better use a 3D software. And we are going to do that together way later by using Blender. Okay, cool. Let's get back to the box example. Why are we going back to the box example? Because we have things to understand. Yeah. We use 3 parameters on the box. And we used 1, 1, 1. If you remember this one, if I use 1, 2, 3, I get something like this. So it's 1 on the width didn't change. It's 2 on the height, and it's 3 on the depth, which is a lot. So we get a shape like this. All right, let's get back to 1, and let's see the 3 others parameters. It's width segments, height segments, and depth segments. These will enable the control of how much triangles you have on each face. So if I get back to my drawings, I will take this again. And if I draw something like our cube, I'm just going to focus on one face of the cube. Okay, that's not bad. Oh yeah. To compose one face, so just focus on this face. To compose this face, the idea is that we are using triangles. So we are going to divide it like this. It can be the other way. It's up to you. You will get the same result. Here, we would have a subdivision of 1. All right? It's the exact name is segments. All right. It's like having segments of 1. If we have segments of 2, it would look something like it will be divided on the 8 by 2, and it will be divided on the width by 2 again. We get something like this. And now, how much triangles you have? You don't have 4 triangles, you get this much triangles. So you get 1, 2, 3, 4, 5, 6, 7, 8 triangles. And it can go on and on like this. If you do it like, we'll do it on the side. If you put 3, it's going to be like this. And you get a lot more triangle. Here, here, here. Oh, never mind. I got it wrong. So it's going to be divided like this, like this, like this, like this, like this, like this, and it goes on and on. And you get a lot of triangles. Why would you need more triangles? Actually, for a cube in which we don't do anything special, we don't need more triangles. It's no use, all right? But if we want to create, let's say, it's going to be a terrain, we are going to create a plane like this. And we want our plane to have like, I don't know the exact word, like heights. Like this, so it goes on, there is a mountain, like this, like this, like this. If all you have are one vertex here, 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 and here, you won't be able to have those details. What you're going to do is divide by a lot. So you're going to divide here, 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 again and again and again. You will have many, many triangles, and then each triangle, so we have one here, one here, one here, one here. You will have obviously, so it's going to be, sorry, vertices. So obviously you will have the corresponding triangles, and then you will be able to move them. Like, let's say I take this one, I will move them a little. I will move this one a little, this one a little, this one more, this one a little, this one more, this one a little, this one more. And at the end, you will have those shapes and you will have details for your terrain. And you will be able to fly above, to play with the car and bump on the hills and stuff like that. So yeah, this is one reason why we could need more segments. We call this also, maybe I use this term, it's subdivision. All right, we are going to talk about subdivision in Blender. It's the same concept, is having more triangles to have more details. Okay, cool. So what happens in my case, the case of this box, if I put more triangles? Let's test. Well, I get the same result because, as we said earlier, having 2 triangles or 1 billion triangles won't make a difference because it's just a flat face. But what we can do is add wireframe true on the material. If you do that, I'm going to do a line break here so you can see it more clearly. Wireframe true, just look at this. You can see the triangles. Wireframe will simply show those triangles, the segments that compose the triangles, and you can just see how it works. You can use wireframe in production to create like futuristic stuff. The problem is that, I don't know if you can see it with the video compression, but you can see this stair-like effect we talked about in the previous lesson, and the width of the segment is 1. Actually, I think some computers can handle a thicker wireframe. Most computers will have a thickness of 1 for the wireframe. So don't count on it to create a thick wireframes. But you can use it. I used it on projects. Cool. So many geometries have a way to improve the details. Not all of them, but many of them. How about we create our own geometries? We can create our own geometries. If the geometry is too complex, as I said earlier, you better use a 3D software like Blender, C4D, stuff like that. But we are going to create one together. So yeah, instead of having this object, I'm going to remove this. Now I can let it, I will just comment it so you can keep it somewhere. And we are going to create an empty geometry like this, new 3.geometry. As you can see, nothing on the screen because I have an empty geometry. There are no vertices, there are no faces inside that geometry. But I have no error, which is a good sign. Then, how can we add the vertices? So keep in mind that these are the vertices. I want to add the small, you can see it's plus, it's the green one here, and it's there, 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 there. We're going to create a very simple triangle just to start with. So yeah, how can we do that? First, we need to create those vertices. To create a vertex, you can do const vertex. I did a mistake. It's not vertice, it's vertex. Vertex 1 equal new 3, and we are going to use vector 3. Because remember that a vertex, it's just one point in space. What's better than vector 3 to create a point in 3D space? So we're going to create a vector 3 with the first one is going to be at the center of the scene. And this vector 3, which is vertex 1, we are going to push it to add it into the vertices property of the geometry. So it's going to be geometry, vertices, push, vertex 1. And you can repeat this process with vertex 2 and with vertex 3, like this. There are many other ways of writing this. So obviously what you can do is put this here, this here, and this here. But I want a code which is easy to understand, but not that short. I forgot to change the coordinates of the other vertices. So this one is going to be 1 on the Y, and this one is going to be 1 on the X. All right, so supposedly we are going to have a visible triangle. If I save, Oh, sorry, I did a mistake. It's not merge vertices, it's just vertices. Oh, okay, it's VS Code that auto-completed. And it seems to be working, but we have an error telling us that 3 direct geometry, faceless geometry are not supported. Okay, it's because we created the points, so the vertices, but we didn't create the face that that use those vertices. So yeah, let's create the face. To create the face, what we need to do is const face equal new 3 dot face 3, and we are going to provide 0, 1, and 2. And I'm going to explain to you this just after. What we need to do then is provide the geometry face by using geometry faces, which is also an array, just like vertices, and push that face. So we create 3 vertices and we add them to the vertices array, and we create 1 face and we add it to the faces array by using push. Push is just JavaScript for putting things in an array. I save, and as you can see, I have my triangles. My triangle. If I put, I don't know, 3 for the y of the second vertex, as you can see, my triangle is much higher. Alright, so it's working well. Why did I put 0, 1, 2? Those are the indices of the vertices. So my vertices array has 3 vertices inside. The first one being at the 0 index, the second one being at the 1 index, and the third one being at the 2 index. This is why I put 0, 1, 2. It's the indices in the vertices array. Okay. A lot of work to create just one triangle, but this is the way. Let's go a little further, and we are going to create a bunch of vertices. And this actually will be useful when you are going to create particles, and create particles like everywhere, just to create, I don't know, snow or rain or like smoke everywhere. We are going just to put vertices everywhere. So let's do something like this. For us, it's just going to be triangles everywhere, but it's the same concept. So I'm going to use a for loop because I want to create multiple things. I'm going to do for let e equal 0, e inferior to, I don't know, 50 is fine. Yeah, it's 50 in the example. Let's follow the example. So I'm going to create 50 triangles, and then because each triangle, each face is composed of 3 vertices, I'm going to loop again. But this time I'm not going to use y, I'm going to use j, and I'm going to do 3 vertices. Then what I can do is geometry vertices and push vector 3, which is going to be new 3.vector3 like this. And in those values, I'm going to put random numbers. So it's going to be math.random, and math.random. I won't follow the example right now because we will explain a little later. It's going to be a better for us. So I repeat, right now we are looping to create 50 triangles. Each triangle being composed of 3 values because it's 3 vertices. We loop 3 times and we create 3 vertices at random position and directly add them to the vertices array. What we need now is create a face using those 3 vertices. So it's not going to be inside this loop. It's going to be after, because we create 3 vertices and then we create one face using those 3 vertices. And it will look something like this. Geometry.faces push. So I'm pushing directly inside of it. Thank you, the suggest. Push. I'm going to create a new 3.face3. And what I need to provide here are the indexes of those vertices. And it's a little harder right now because we need to not mess with the index. This index is doing 0, 1, 2, 3, 4, which is the first triangle, the second triangle, and the next triangle. But the indexes of the vertices are going 3 by 3, because we are adding 1, 2, 3 values, and then 1, 2, 3 values, and then 1, 2, 3 values. So I'm going to create a temporary variable, which is going to be vertices index, and it's going to be y multiplied by 3. This way I get 0, 3, 6, 9, 12, 15, etc. Okay, cool. And then I'm going to provide those indexes. It's going to be vertices index plus 0, because it's the first one, I can get rid of it. Vertices index plus 1, and vertices index plus 2. So these are just the indexes of the vertices that we've just added right now. Inside this loop, we are adding 3 vertices, and then we are providing the indexes of those vertices. Yeah, it's quite hard. It's going to be simpler after. I'm going to show you another way of doing it. So I don't know, maybe I did a mistake. Let's test this. Oh no, it's working. Look at this. I get a bunch of triangles randomly. The problem is that when I refresh, as you can see, they are all inside a 1 by 1 cube, and it's not centered on the scene. It's because I use mathrandom. Mathrandom, if you test it in the console, you see that it always gives you something between 0 and 1, like that. So it's okay, it's what we intend from those kind of functions, of methods, but we want a bigger cube and we want it to be able to be negative as positive. So there are many ways of doing this. What I like to do is use minus 0.5. And this will get me, the mathrandom will be between minus 0.5 and plus 0.5, positive 0.5. So it's as much negative as positive. I like to do it that way. Then I will put it inside parentheses and multiply by any value. I can use 4. And I get something like this, which is a good start, at least. Next, we are going to talk about buffer geometries. If you spend some time in the documentation, you might have seen, so I don't have it anymore. Let me open any one of them. Yeah, this one. Cool. Okay, get back to the buffer geometries. If you type geometry in the documentation, you can see all the geometries we talked about previously, but you can also see buffer geometry. Let's take our box. There is the box geometry, but there is also the box buffer geometries. And it's the case for almost every geometries. So what are those buffer geometries? We need to understand those because we are going to use them every time. So yeah, buffer geometries are more efficient and optimized, but less developer friendly. The GPU and the computer will handle buffer geometries more easily, much more easily. So we have to use them for performance reason. The problem is that it's harder to create vertices and create faces when we are using buffer geometries. It's going to be a lot more code with new concept and very interesting concept, but we have to use them for performance reasons. So yeah, let's get back to, I'm going to remove all of this. You can just comment if you want and get back to my cube, which was like this. So this is my cube and I can convert it and use box buffer geometry like this. I get the exact same result. All right. For now, there are no reason not to use buffer geometries. When it's simple built-in geometries, just use them. It has no cost. Just use them and your WebGL experience will have a better frame rate, will be better in terms of performances. So for built-in geometries, just use buffer geometries. The parameters are the same. As you can see, I can put more segments, so more subdivision. It works just like that. All right. Things get a little harder when it comes to create our own buffer geometries. We are going to do the same as before, meaning that we are going to create a triangle and then create a bunch of triangles, but now by using buffer geometries. A buffer geometry. So yeah, we can start. Before creating the geometry, we need to understand how to store buffer geometry data. Remember that what we need to do is store data, store the vertices. We can store more things like the position, UV, normal, but in our case, we just need to store the vertices coordinates. And then we need to create the faces. So how can we do that? Before creating the buffer geometries, we are going to create those data, and we are going to use a float32 array. This is native JavaScript. It has, for now, nothing to do with Three.js. All right, this is the document, one of the documentation of float32 array, and you can create one. Here you can find some examples. Float32 array or typed array. A typed array in JavaScript can only store one type of value. In our case, because it's a float, it can only store floats. All right, you cannot store booleans, you cannot store another array inside of it, you cannot store strings, you can only store floats. It has a fixed length, meaning that if you say that your array can handle, 3 values, you cannot put more than 3 values inside of it. And it's much easier to handle for the computer. It's really, really easy for the computer to handle those. So we better use this. We have to use this, actually. There are two ways of creating and filling a float32 array. So we want to add the vertices position by using a float32 array. How can we do that? So we can start by, unfortunately, don't test the code we are going to do because we are missing the geometry. All right, so if you test this code, we have the material, you will create the mesh, but the geometry doesn't exist, so we get an error. We are just discovering the float32 array. Don't worry, we will get back to our geometry soon. So I'm going to create this float32 array. I'm going to do positions, careful, I put an S here, array equal new float32 array, like this. And I'm going to use 9. Why 9? We will get back to this shortly. And then I'm going to add, oh, sorry, there is an error in the code. I have to fix this. Poof, fixed. The magic of editing. So yeah, we are going to fill this array, which has a length of 9. I'm going to explain to you why 9 right now, actually. And we can fill this array with values. And we are going to do this, 1, 2, and use 0, 0, 0. And you will understand why those values. At the 3, 4, and 5 indices, we are going to use 0, 1, 0. And then 6, 7, and 8, we are going to use 1, 0, 0. Yeah, that's it. 1, 0, 0. And you probably understand why we used 1. A float32 array is a one-dimension array, meaning that you have to put all the value in that array. You can put arrays in arrays, or objects in that array. With object with X, Y, and Z, you cannot do that. So you have to put every values in that array. And here we put the values of the first vertices. This is going to be the X, the Y, and the Z. Then this is the second vertex. And we will have the X, the Y, and the Z. And this is the third vertex with X, Y, and Z. So this is why we have to provide 9 values. Because we have 3 vertices, we are creating a triangle, and each vertices has 3 values, X, Y, and Z. So this is one way of doing it. The other solution is to send an array directly, and we will send just the values like that, 0, 0, 0. And I will add a line break. It's going to be 0, 1, 0, a line break, 1, 0, 0. And it's exactly the same as before, because the first three values are for the first vertex. This is the second vertex, and this is the third vertex. All right, do not refresh. You're going to have an error because we are not creating the geometry. So yeah, this is the concept of having those values is one array. I can actually just make a draw to it to make sure that everyone understood this. This is your array, so you get something like that. You get values inside that array. So this is the first value. I don't know what it's inside, but this is the third value. This is the second value. This is the third value. This is a new value. We are going to put even more of them, even more of them, even more of them, even more of them, even more. All right, we have enough. So this is a one-dimensional array. This will be the x, y, and z of the first vertex. This is the first vertex. Then we are going to have the x, y, and z of the second vertex, like this. And then the third vertex, like this. X, y, and z. And it's so much easier for the computer to handle those. Here we get something like this, as you can see. And it continues on and on like that. So this is why. Okay, cool. What can we do with that array? We need to convert it to a Three.js buffer attribute. This is a buffer attribute. So how can we do that? What we can do is create that attribute. So it's going to be positions attribute equal, and we can create new three buffer attributes. So now it's buffer attributes. Yeah, it looks like this. And you provide that float 32 array. Hang on, it's almost there. You provide that float 32 array, and you need to add a number here. And I put 3. And this is exactly what I've just shown you. We say that one vertex contains 3 values. One vertex in that array, you need to go 3 by 3, like this. So this is why we provided 3. If we are using UV coordinates, for those who know about UV coordinates, we will just say 2, because UV coordinates, it's just 2 values per vertex. If we are sending, let's say, just a random value for let's say the size of the particle, it's going to be the same thing, but we will say just 1, because 1 will be the size of the particle. So it's just going to be one element in the array. And we are going to do that. So don't worry if it's still blurry. We are going to do that together later, because we are going to practice. All right. I know you cannot understand everything on the first go, and we need to practice to really understand. Then what we can do is send this attribute to the geometry. I forgot to create the geometry, so I'm going to do it there. Const geometry equal, and this time we are going to create 3.buffer geometry, just like that. Geometry, yeah, like this, without anything else, no parameters, just an empty buffer geometry, not a geometry, it's a buffer geometry. And to add this attribute containing the position, we are going to do geometry set attribute. We are going to choose a name for this attribute. We are going to say position, so it's a string, and then send the positions attribute as a second parameter. If I test this, refresh, I get my triangle. All right, it's the moment you can refresh and test if you did some mistakes. If so, just pause the video, find your mistakes, you will have information in the console, and get back to the video when it's done. So why did we use position here? If I put anything else, it doesn't work anymore. This is the name of the value of the attribute we are sending that will be used inside the shaders. Ooh, the shaders. Shaders are hard, all right? And we will learn shaders together. Anyway, Three.js has built-in shader. When we are showing this triangle, it's Three.js shaders handling this. So it's okay, we don't have to write our own shader, but those shaders have been written with a name for this attribute, which is position. So we have no choice. We have to use the name position here if we want those shaders to work with our attribute. All right. Yet again, we are going to do shaders together, and we are going to send different attributes together. Do not worry. We are almost there. What we are going to do, as I said earlier, is create a bunch of triangles. And this is the good part because it's going to be much more simple. One more information is that we didn't provide faces, all right? It was handled automatically. We didn't have to say this is one face. This face is composed of this vertex, this vertex, this vertex. So we just send a bunch of vertices, and the Three.js and the GPU and the shaders just compile it as it should be. Okay, let's create a bunch of triangles. What we are going to do, let me see, let's put the geometry on top right here. Instead of doing this, we are going to create one float32 array. Yeah, you know what? Let's get rid of everything and do it again. Yeah, we are just going to have our geometry with nothing inside. So if I save, I get nothing. First, we are going to decide on how much triangles we want. So I'm going to create a count variable with 50. You can change this value, but let's start with 50. Then I'm going to create the positions array. And it's going to be, try to do it without looking at my screen, at the video. It's going to be a float32 array. So this is native JavaScript, and we are going to write here the length of this array. So it's going to be count, and I'm going to multiply it by 3, and then by 3 again. Why? Because I need to provide a lot of values, and each triangle. So I want to create 50 triangles. Each triangle will be composed of 3 vertices. And each vertex will be composed of 3 values, which is why we need to multiply by 3 and by 3 again. All right. I always get this one wrong. Do not worry. It's really easy to mess this one. All right. Now, and it's the really easy part, we need to just fill that array, that float32 array, with random values. And we don't need to think of doing a loop inside another loop. We just need to fill that array with random values. To do that, we are going to do let I equals 0, I inferior of count, multiply by 3, multiply by 3. Well, it's the length of the array. So this is the same code here and here because we just want to fill it with random values. And then y++, which is simple JavaScript. And then we can just fill that array at the y index with random values, and we are going to use math random as we used before. We are going to update this one once we can see the results. Then what are we supposed to do? Try to remember how we can do that. We are going to create an attribute. So to create the attribute, you are going to do positions attribute equal new 3, and it's going to be buffer attribute. We are going to send our float32 array, and don't forget that you also need to provide how much values the program is supposed to take for one vertex. So For us, it's 3. And then once we have our attribute, we need to send this attribute to the geometry, the buffer geometry. To do that, we are going to do geometry, set attribute. We're going to use position because we have to. This is how it's going to work. Later, we are going to create our own attribute and our own shaders, and we are going to change the value here. And we just send the attribute here. Did I do a mistake? No, it's working great. As before, just like before, we are going to change this math random, which is kind of sad. We are going to do minus 0.5. Look at this. Now it's centered. If I remove it, it's from 0 to 1 and from 0 to 1, and in depth, it's from 0 to 1, 2. And if I put minus 1, it's from minus 1, positive 1, minus 1, positive 1, minus 1, positive 1. And this we can multiply by anything, let's say 4, just like before, and we get the same result, but using buffer geometry, which is more performant. And if you want to have fun, let's add a lot more triangles, and it's running perfectly. You want to test even more? Still perfect. I can't see much, but it's working just fine. I can put myself in the middle and see absolutely nothing because there is too much. Still, my computers can handle this perfectly. Don't burn it by putting too much. It's your problem. All right, just a small final word about index. Some geometry have faces that share common vertices. The cube is a good example. As you can see, the vertex right, let's say I'm going to use a purple. The vertex right here is used for this triangle. Going to write this triangle, all right? This triangle, this triangle, this triangle, this triangle, and this one. So sometimes you have vertices. It depends on your geometry. For our triangles, it's not the case, but sometimes you have geometries that can, triangles, sorry, that can share the same vertices. What you can do is use index. You will provide all the indexes and just say that the first triangle is composed, is using this vertex, this vertex, this vertex. It's better because you will have less data to send to the GPU because you will have less vertices, but it's harder because you have to organize your code and structure and the logic behind so that you send the right indexes. So it can be a nightmare, but you will improve the performances by doing this. We won't do that here because it's not very interesting, but I had to talk about this, and you can change the index if you look for index. So yeah, you have actually examples right here. You can follow those examples, and it's like here. Yeah, this is the index buffer attribute. It's a buffer attribute too. All right, we are not going to see this right now. And that's it for the lesson.